move it down. Check this, man.
I can't remember. What's the thing where we have to swap the x and y?
Yeah. So, so that would be true for tan. So it's a reflection in the line y equals x. So this one, y equals tan x. You swap the x with the y, so it's a reflection in the line y equals x. And then you get y equals arctan x. The difference is this has been they've done some stuff. So a tan graph, what are its features, what are its asymptotes and stuff?
I think 90.
So that is pi over 2.
Yeah.
Okay. And so if we were to swap those around, I believe it would look like that. And its asymptote would be y equals pi over 2 instead of x equals pi over 2. So that's pi over 2. That's minus pi over 2. What did they do to this? What transformation has happened here?
Plus b.
Any idea what b is? They also did times a at the front.
No.
I think so. Pi over 2 times what gives you pi, because it moved up to pi and down to minus pi.
Wait, I'm kind of confused.
I'm not really sure if it's the most efficient way of going about it, but so you could sub in minus 3 and 0. So 0 equals a arctan minus 3 plus b. Minus 3 plus b. So it's basically been moved b to the, well, okay, where does this one, what's the y-intercept on y equals arctan x?
0.
Yeah. And so 0, 0 became minus 3, 0. And so what happened there? What does that tell you about b?
It's minus 3.
So b must be minus 3. Yep. B must be minus 3. And so 0 equals a arctan minus 3 minus 3. You can do it that way, or pi over 2. So it was the asymptote was pi over 2. The asymptote became pi. So pi over 2 times what gives you pi?
Two.
Yep. And so value of a?
2.
Yep. So a is 2, b is minus 3. Basically, y equals arctan x looks like this one down here, sorry. This is tan x. This one down here is arctan x. It goes through 0, 0. The new one went through minus 3, 0, so it must have moved 3 to the left. In fact, that would be b is plus 3. Because it works the other way. X plus 3 would be 3 to the left, I believe. And then it used to have maximum minimum pi over 2 minus pi over 2. That became pi, and so they must have done stretch scale factor to y direction. So a would be 2. Let us check 2 and 3. Oh, there was a part B. Find the coordinates of the point where the curve... Okay, find the y-intercept of y equals 2 arc tan x plus 3.
So x is 0, so do you just sub in that?
Yep.
Is arctan the same as tan to the minus 1 on the
Yep.
calculator?
Yep.
I got 2.498.
And so 0, 2.498 is that radians? 0.2498. That's it. Yep. Any questions there?
No.
Okay. But big picture is knowing that what y equals tan x looks like, therefore what y equals arc tan x looks like, and then transforming it. Okay, let us try this.
So that's like cos to the minus 1 of x minus 3.
Mm-hmm.
Would you do like when we do let x minus 3 be equal to a or something?
So I like it. Let's not though, because it says the exact value, so they only want one value.
Okay. Could we like rearrange it or something then maybe?
Yeah. How would you? So what you're aiming for is x equals. So how do you get rid of all the other stuff?
You have to divide minus pi over 4 by arc cos.
Kind of. What is the opposite of arc cos?
Cos.
And so you don't divide it, you just do cos to both sides.
Oh, okay. And does that cos cancel out the arc cos on the left side?
Yeah. So what remains?
X minus 3
Yeah.
equals cos minus pi over 4.
Yeah.
And then x equals cos minus pi over 4 plus 3.
Mm-hmm.
And then can you type that into your calculator?
Yep. And I'll even write it as 3 plus, so we don't accidentally put it in the bracket.
I got 6 plus root 2 all over 2.
6 plus root 2 all over 2. They wanted an exact answer. 6 plus root 2 all over 2. But big picture there is the opposite of cos is arc cos. Sorry, the opposite of arc cos is cos. Yep, do that to both sides. Any questions there?
No.
Okay. Here we go. Why would you ask me to do this topic? Okay.
Ooh.
Correct reaction.
What's that little arrow, you know, between the X and the arc sign? Like, what is that?
It's just a different way of writing the f of x is equals. It's f such that x maps onto basically its function.
Okay. So f of x equals arc sine x. Okay. So sketch the graph f of x.
So how do you sketch the graph of y equals arc sine x?
You swap y and x.
Yeah. I want to try cheating and just putting it in my calculator. But you can do it that way as well.
So what would you put into your calculator?
How do you put in arc sine?
Oh, sine to the minus 1.
Yeah. My only concern is being able to see the stuff. So I always get the zoom wrong. Maybe a little better look. Okay. So graph. Oh, that there. There you go.
Oh.
Okay. What are the... Oh yeah, so they told me. So x is between minus 1 and 1.
Yeah.
And that's because usually y is between minus 1 and 1. Okay. There you go.
So what would the range be of f?
You tell me. Look at your graph.
Minus 90 and 90.
Yep. Although they didn't... I don't see radians anywhere, so who knows. And two ways we can say this. We can say y is between minus 90 and 90, but just for the sake of clarity, y equals the f of x. So I'm going to say the f of x is between minus 90 and 90. And that's because maybe the g of x is like something different. Like there's in case there's lots of y's going on. Okay. How about b?
So does that mean like if it's inside the bracket, then there's like a stretch, but I don't know which one.
Which direction, x or y?
X.
Yep, because it's in a bracket next to x. Scale factor.
Is it a half?
It is. If x becomes 2x, then x equals a half. Okay, go on.
So the points from the graph we just did were minus 1, minus 90. So if you were stretching it by a scale factor of a half in the x direction, then you would do -1 times a half.
Uh-huh.
And the new point is -1/2 minus 90.
Yep.
And for the other one, it would be 1/2 90.
Yeah. What about the y-intercept?
Oh, 0.
Yep. Stays the same. And so it's now going to look something like that.
Okay.
Furthermore, ooh, hang on, it's weird. Furthermore, seeing as how you love working so hard, exit file, capture screen. That was arcsine x. What if it was arcsine 2x? There you go. And it's the same idea.
Okay.
I'm just never good at. There's probably some way to get graphical solve, like, yeah, the minimum. That'll work, won't it? Hey, not found. See, I never know how to use this thing. Okay, let's see.
The domain, is that like the range?
Mm-hmm.
So, -1/2 and 1/2.
So that's -1/2 x and 1/2, and this thing, this other part.
So that means x. I'm not really sure.
G such that x maps onto, I believe it is just, I don't know. The g of x is equal to the f of 2x. Another way to write that is it the f of 2x like that? Ooh, I don't know. I have to check. So our first one, the range. Okay, so they give the range in radians. We couldn't have known that. So the domain, arcsine 2x. Arcsine 2x. Ah, okay. So instead of f of 2x, it's arcsine 2x. How could we have known that? To find g in this form. So the f of x, f such that x maps onto arcsine x. And so g of x equal to f of 2x. And so g such that x maps onto arcsine 2x. Okay. And how about d?
To the -1. Is that like the inverse of it?
Yep.
So like minus.
Nope. What is the inverse of arcsine x? Sorry, arcsine 2x?
Sine 2x.
I think so. Sine, 1/2 sine x. Oh, yes. This malarkey. 2 marks. Okay, hold on. Better get back in time. We're going back in time to GCSE. Inverse functions at GCSE. Hang on. Another way to write this thing is g of x is equal to arc sine 2x. Do you remember from GCSE you replaced this with y equals, then you swap the x and the y to get the inverse. Then you have to make you have to make y the subject. So make y the subject there. What do you get? Or how do you do it?
You have to sine both sides. So we get sine x and is equal to 2y. So then y equals sine x divided by 2.
Yeah, alright, it is a half sine x, just so we don't accidentally put it in the thing. And this, so we said y was the g of x. We swapped g of x with y just for sake of simplicity. We could leave it as y, but we'll turn it into their one. It's like, yeah, g inverse thing. So, hang on. What do they... I should write it like this, I think. G minus 1 of x. And so, such that x maps onto a half sine x, because that's the inverse. A half sine x. There we go. I don't know, GCSE, did you do this thing where you had to do inverse functions? And so you have like the f of x is equal to something, and you just let that be y. You swap the x and y, you make y the subject, and then you turn it into that. Did you do that at GCSE?
I think we did.
Yes, that means yes. Okay. Let me see. But big picture. Sketch the graph. Do it as a reflection of y equals x or calculator. Swap x with y for domain and range, and I wrote f of x. Turns out I didn't really need to, but they might have asked for g of x stuff. Let me see. Yes. All right. Any questions there?
No.
Yeah. Or many questions. Okay. Oh, let's try this.
Would you cos and sine both sides?
In theory, let me see. In practice, I think we might have to square both sides. Let's see. If we cos both sides, we got what? X equals cos arc sine this. Hang on, prove that for between 0 and 1, arc cos x equals this. Okay. Any ideas there?
I'm not really sure.
So my guess is this square root of 1 minus x squared, that's going to be like square root of 1 minus cos squared or x, or square root of 1 minus sine squared x. Arc sine. Yeah, hang on. What? I'm not even beginning this thing. Let y equal arc cos x. Yeah, see, they snaked me. I knew there was something like that. Okay, let y be equal to arc cos x. And so y equals arc sine 1 minus x squared. Okay, make x the subject.
So square both sides.
Not yet.
Sine both sides.
Yeah.
So then we get sine y equals the root of 1 minus x squared.
Mm-hmm.
And then we get, then now you have to square both sides.
Yeah.
So sine squared y equals 1 minus x squared.
Mm-hmm.
And then sine y.
Make x squared the subject.
So x squared equals 1 minus sine squared y.
Okay. So right. So we got x squared. If we were to hold on. Arc sine. So is there some what is sine squared y equal to? Yeah, sine squared y is equal to 1 minus x squared. Yeah. Sine squared y is equal to 1 minus x squared. And so arc sine, let's just work on backwards kind of. I don't know if I'm even on the right track. Oh, okay, hang on. So sine squared y is 1 minus x squared. And so you can replace sine squared y with 1 minus cos squared.
Okay.
And so what is cos squared y equal to?
1 minus x squared minus 1.
I believe it's just x squared.
Okay.
And so arc sub that into there.
What do you mean?
So x squared is cos squared y. And so instead of 1 minus x squared, you could write that as arc sine 1 minus cos squared y. So x cos squared y and x squared are the same.
Yeah.
So I just replaced x squared with cos squared y.
Okay.
What else is 1 minus cos squared y equal to? This is what you must never forget.
1
So what is 1 minus cos squared y the same as?
Sine y.
Sine squared y.
Oh, yeah.
So arc sine square root of sine squared y. What is the square root of sine squared y?
Just, wait, yeah, just, do you have to do plus or minus? Or no?
No.
Just sine squared y.
Squared and square root cancel each other out. Sine squared y means sine y all squared. And so you're left with arc sine sine y. What happens to arc sine and sine?
They cancel each other out.
So what are you left with?
Just y.
What did we let y be equal to?
Arc cos x.
And so I think that does it. We showed that arc sine square root of 1 minus x squared. Monkey around with it a lot. Eventually it becomes arc cos x, which is what we had to show. Hopefully that's not circular or something. Let's see. I'm sure they did it in some very efficient way. Let's see. So let y be equal to arc cos x. Cos y equals x. So x squared equals 1 minus sine squared. Yeah, and then you just square root both sides. Believe it or not, that's how we were supposed to do it. Any idea about b?
Because it's negative.
Yeah, that's true, because you can't have a square root of a negative. So it's basically outside the range. Can't square root negative. Okay, hold on. Let's do a again for your sanity. So the big trick here is let y be equal to arc cos x. What's first step?
Swap y and x.
You're thinking of inverse?
Oh, cos both sides. So cos y equals x.
Yes. What you forgot was our identity. Sine squared x plus cos squared x is identical to 1. And in fact, I'll just call it y. Because it's always the same thing. Theta. Okay. Cos y equals x. What is cos squared y?
1 minus sine squared y.
Yep. In terms of x?
X squared.
Yes. And so we have to have just x's in our answer. Equal to 1. Or I could leave as equals. Okay. Equals 1. So we are trying to move towards, what is sine y equal to? How do you get that?
Sine y. From sine squared y.
Yeah, from this.
Yeah. square root both sides.
Or what is sine squared y equal to?
1 minus x squared.
Yeah. And now do your square root both sides for sine x.
Square root 1 minus x squared.
And so what is sorry, that was y. What is y equal to?
You have to do sine to the minus 1 of root 1 minus x squared.
Yeah, and another way of saying that is arc sine.
Okay.
Minus x squared. Done. Y equals arc cos x. Y equals arc sine root 1 minus x squared. And so arc cos x equals arc sine 1 minus x squared. Yeah, so we let, just for the sake of ease, we let y be equal to arc cos x. Cos both sides. Cos y is x, so cos squared y is x squared. Sine squared y plus x squared is 1. Sine squared y is 1 minus x squared. Sine y is the square root. Y is the arc sine. And y is also arc cos x. And so arc cos x is arc sine root 1 minus x squared. Any questions there?
No.
Yeah, trig. Hey, that's the end of it. Okay, so summary of key points. Third letter is that thing. Okay. Cot, so tan is sine over cos. Cot is cos over sine. Learn these graphs, or calculator, preferably learn. So that's 1 over cos. That's 1 over sine. That's 1 over tan. Identities. How do you prove 6? How do you prove those identities? Using what they give you.
You change the sec to 1 over cos squared x.
No. So this one here, sine squared x plus cos squared x is identical to 1.
Mm-hmm.
You divide everything by sine squared x to get one of them. And then to get the other, you divide everything by cos squared x to get the other one.
Okay.
That's where they come from. Inverse function of sine x is called arc sine x, so that it's a function. For it to be a function, it has to have an inverse function, and so it can't have the same y coordinate twice. And so they have to restrict it. So they restrict it between the x between pi over 2 and minus pi over 2. And then you just swap the x's with the y's. Same with arc cos x. Same with arc tan x. And you do a bunch of malarkey, like tan to both sides. Trig functions.
Definitely half.
Hey. I told you it was the hardest thing in A level. Let's see. You said 7. I downloaded it. I didn't open it. Is this more trig? Holy God.
Oh my gosh.
Trig and modeling. Okay. Modeling means applying it to the real world. My least favorite of all worlds. So it's going to be the stuff you've already been doing, except now it's applied to the real world. So actually the trig is easier, but you just have to know kind of like which one to use, when to use it, that type of thing, because you're applying to real world. Did you see these before?
No.
No. You cheat this man. So these are given. I have a thing to show where they all come from and stuff.
Okay.
For example, we'll use them. We'll use them first. and we'll prove later. I'm sure they'll make me prove them if we have to. So this is where the first one comes from. Fascinating stuff, absolutely fascinating. They give you the formula. You don't need to prove nothing. If they give us an exam question, so this is just to prove where these formulae come from. We'll do one. Okay, this formula here, which is given to you, bunch of malarkey. A right angled triangle where one of its angles is made up of two parts being added together. It has a hypotenuse of 1. Fascinatingly, do a bunch of malarkey and you figure out that the sine of that angle, a plus b, is the same as sine a times sine of the a part plus the cos of the b part times plus cos of the b part times sine of the a part. Okay, into this formula, sub in minus b. So let b be equal to minus b. And so you get sine of a plus minus b, which is sine a minus b. Do the same thing on the right side. Wherever there's a b, change it into a minus b.
Why?
Sorry?
Why?
We're proving stuff. You cheaters, man. Sine a cos minus b plus cos a sine minus b. What do you know about the cos graph and stuff, like cos minus 45? What's that the same as? Cos minus 11.
You mean like the values that mean the same?
Yep.
So you didn't use a cos diagram?
I suppose you could. Cos minus, I'm using 30. Cos minus 30 is root 3 over 2. Cos 30 is root 3 over 2. It's symmetrical about the origin. What does that tell you about cos minus b?
Does it go the opposite way through the origin?
Cos minus 30 is the same as cos 30. In general, cos minus b is the same as? Cos positive b. Cos minus 15 is root 6 plus root 2 over 4. What do you think cos positive 15 is?
Minus that.
It is the same thing. It is It is symmetrical about the origin. So you have your cos graph like that, and it's symmetrical. So it's the same thing. So that there is just the negative. The negative version gives you the same y. Sine minus b. Any idea what that's the same as?
Sine b.
It is the same as minus sine b. And if we simplify that, we get sine a cos b minus cos a sine b. So I just put the minus there. And that proves our second formula. And you can continue to prove all these formulae. And if they make us, they make us. If you have to prove this one, you just sub in minus b instead of b and use some angle facts. But they are all given to you. Okay?
Okay.
Okay. Hold on. Let me copy. So I have a good lesson for this shizzle, but I want to just make sure I'm sticking to exam questions. If I need to, I can get it. Use the results from example 1 to show that. Okay, so how could you use this result, cos A plus B, to get cos A minus B?
With the rules that we just did of, so if you have cos A, it's the same as cos minus A.
Spot the difference.
The first one is A plus B and the second one is A minus B.
So let B be equal to minus B. Wherever there was a positive B, you replace it with a negative B.
Okay, so cos A, cos minus B, plus sine A, and then sine minus B.
It was minus. That's a minus in between them. Minus sine A, sine minus B. Cos minus B is the same as?
Cos B.
Sine minus B is the same as?
Minus sine B.
Yeah. And so what is minus sine A times minus sine B? Minus times minus?
Plus.
Yep. And there you have subbed minus B for plus B, and you ended up with this second formula. Cos A minus B is the same but with a plus in the middle. Tan. What is tan the same as?
What do you mean?
In terms of sine and cosine.
Tan is sine over cos.
Yeah, and so if you had to prove tan A plus B, we just used sine A plus B. We just used cos A plus B. And what is sine A plus B the same as?
Sine A minus B. Oh, sine A cos B plus cos A sine B.
That goes there. What is cos A plus B the same as?
Cos A cos B minus sine A sine B.
That goes there. You do a bunch of malarkey and you end up with this here. Tan A plus tan B over 1 minus tan A times tan B. If they make us prove this stuff, they make us. If they don't, I'm not doing it. Prove. Holy God. Right? Yeah, looks like we're doing this one. Okay. How do we do this? My guess is you add the fractions. Like you combine the fractions.
So you have to make the denominator the same. So we have to the first by cos B.
Yeah.
So then we get cos A cos B over sine B cos B. Minus, then we times this one by sine B, so we get sine A sine B over sine b cos b. So then overall we get cos a cos b minus sine a sine b over sine b cos b.
Yeah. And look up in our stuff here. Can you find cos A cos B minus sine A sine B?
Is cos a cos b the same as cos bracket a plus b?
Yep. And I believe that's what we had to prove. And so the way you prove it is you just combine those two fractions, like a common denominator, and then look it up and swap it. And this is the type of thing where I wouldn't have something similar to this, but I wouldn't have something like this. So I'm glad I did this. Any questions about that?
I'm confused on where did the minus sine a sine b go?
What is cos A plus B the same as?
Oh, okay.
Yep, that whole thing is the same as cos A plus B.
Okay.
Okay. Yeah, I like to say don't overthink it. No. Let's greatly overthink this stuff. Yep. Okay. Stuff's getting very real. Very fast. Wait, this one, not this one. I got a better one. There we go. Okay. Let's try this. What is sine x plus y the same as?
Sine x cos b plus cos x sine y.
Yep, and it's that whole thing times 2. So I'll just do 2 and then that. Okay, how about the second one?
3, so cos a minus b, so cos x cos y plus sine x sine y.
Yep, what's next? What are we aiming towards?
Tan x in terms of tan y.
Yeah, so what we're aiming towards is tan x equals.
So we have to, should we divide by cos?
Very good. Yep. And in fact, I'm just going to expand these brackets. So that one's going to be 2, 2. The other one's going to be 3, 3. I don't know if that's better or worse. 3, 3. So we divide everything by cos x, is it?
Yeah.
Let me have my fun. Hold on. In terms of tan y, that means we can't have any sine y or cos y. How will we get tan y?
Divide by cos y as well.
Yes. So let's do that in one go. Divide everything by cos x cos y. Okay, what do we get there? What do we get?
2 tan x. No.
Yeah.
Yeah. Okay. Plus 2 tan y.
Yep.
Is it just 3?
Yep.
Okay. 3 tan x.
3 tan x.
Tan y.
I believe so. Okay, we want tan x equals. How do we go about that? On one side by itself.
So 2 tan x equals 3 plus tan x tan y minus tan y.
You have the right idea. I'm going to do it in one go. Bring that one over. Problem is we have 2 tan x's. We want just one.
So you're going to have to divide by tan y.
Then this one would be over tan y. So problem with that is you'd still have a y on the left side. Factorize.
So tan x, so 2 minus 3 tan y.
And so what is tan x equal to? How do we get rid of times 2 minus 3 tan y?
Divide.
Yep. What do you get?
You just tan x. Three minus 2 tan y over 2 minus 3 tan y.
Great. 2 minus 3 tan y, which is what they asked for. They wanted tan x on one side and tan y on the other. We've nothing but tan x on one side, nothing but tan y on the other. No sine, no cos, no also stuff here. 3 minus 2 tan y over 2 minus 3 tan y. Let us see. Let us see. We have an addition formula here. Sine something plus something else. Cos something minus something else. And so we can change those into just sine x, sine y, cos x, cos y using our formulae, and then divide everything by cos x, cos y to turn everything into tan. And then make tan x subject, by factorizing. If you have more than one term and you need just one, factorize. Any questions there?
No.
So much more to do. So much more to do. Hang on. It's very similar. Let me see. If you have some extra time, we can do this one. It's up to you.
Sure.
It's just while it's fresh in your mind. All right, let's give this a go.
So before, weren't they in two separate fractions that were being added?
Yeah.
So do we make it into that form?
No. What is cos x minus y the same as?
Cos x cos y plus sine x sine y.
Yeah.
And then over sine x plus. So sine x cos y plus cos x sine y.
X. And I'm going to do it as two different things divided.
Okay.
Plus cos x cos y. Okay. What is next? We want tan x and tan y.
divide by cos x and cos y.
Yeah, so divide the top and bottom by cos x, cos y, and so that will keep everything the same. And I visualized it this way as divided by instead. Okay, what do you get?
So tan x tan y divided by tan x tan y. Wait, does that make sense?
Too quick for me. Let's see. So that is, if you divide this, what do you get for this first one?
1
1
plus tan x tan y divided by.
And I'm just going to do over again instead of divided by.
Tan x tan y plus 1.
Okay, so that's 1 plus, are you sure? Tan x tan y. That can't be right. X tan y. Cos x cos y. Minus. Was there minus wrong in here? Cos x minus y is cos x cos y plus sin x sin y. Yeah. And then sin x sin y plus cos x cos y. We then divide the top and bottom by cos x cos y to get tan x and tan y. Cos, that is 1. That is plus tan x tan y. That is tan x tan y. That is 1. It's saying it's plus. I don't have a word solution. 1 second. So, let me see. Are there any other similar? Prove. Well, there aren't any similar. I'm not gonna lose. I think they just changed. Ah, I know what they did. Wow, that's sneaky. Hang on. Tan A plus tan B. Yeah. Hang on. Why would they make my life that difficult? This one here. Something like that. Something like that. They messed around with this again. And so you can see tan A plus tan B. Tan X plus tan Y. So they messed around with it a second time. I won't mess around with it. Okay. How's that for you, Keelan?
I'm good.
Yeah, we need to do this stuff. And so we'll continue this next time? Or
Yeah.
something different? Alright. Any questions?
Sorry, we can do this.
Sorry?
No. We can do this, yeah.
Okay. Any questions for me in general?
No.
Alright, well done, Keelan. You did great. I look forward to chatting again next week.
Thank you. Have a good week.
You too. Goodbye.
Bye.